All right, in this part of the course, we're going to take a closer look at functional programming. So functional programming is a different paradigm of development, and there's some very key features of functional programming. If you want to be leveraging reactive programming and streaming technology, you really need to get functional programming down because there are some very important nuances about functional programming and the style and how it applies to processing streams in reactive programming. Because a lot of times when we're dealing with reactive streams, you're dealing with a stream of data and you want to be using a functional programming style. If you get these concepts down, it's going to make your life a lot easier. So these are some very foundational stuff. If you are already comfortable with functional programming in Java 8, all the goodness we got in Java 8, go ahead and skip over this section because we are just going to cover the fundamentals of functional programming with Java. All right, in this video, we are going to take a look at what functional programming is. So we're going to try to get to a definition of it and get you a better understanding of functional programming. Now, here's a little graphic that I found on the net. Charles Scalfani, I think that's how you say his name, posted it on a pretty interesting article about functional programming and kind of like a little evolutionary track there of Homer. And it is definitely a paradigm shift as you move through each one of these stages. I entered the programming world. I never have done machine or assembly. I definitely jumped right in with procedural where you do statement after statement after statement. And that's how the code works. I used to do, I hate to admit it, but I started off doing basic and Visual Basic and as I entered into the enterprise, I used to do a ton of SQL and PLSQL with Oracle. And then, 15 years ago or so, I made the transition to OO, and that was quite a paradigm shift. I remember really struggling with it because it was such a paradigm shift. Now, functional programming is something similar. It is quite a paradigm shift to wrap your head around. So don't get frustrated as we get through this because the functional programming is extremely important to reactive programming. And we're going to get a good foundation of functional programming so we can leverage it with the reactive streams inside of Spring Framework 5. So imperative programming, going back to this slide there, so within the objects, when we do procedures within an object, within a method, we do A, B, C, D, and E. So kind of like procedural, so we have like mini procedures within object methods. So similar to that, we have imperative programming. And this is a kind of a long, drawn-out definition from Wikipedia saying in computer science, imperative programming is a programming paradigm that uses statements to change a program state in much the same way that imperative mood in natural language expresses commands. An imperative program consists of commands of a program to conform. So like I said, it's going to be a series of statements to go through and do multiple things. So let's take a look at an example of that. So we've all seen this, and we're going to take a closer look at this upcoming in the course. But here we want to get a count of dogs with more than 6 characters in their name. So we create a variable dog count, and then we iterate over the list, and we increment the dog count, and at the end of it, we print it out. So we start with a list, we set up a variable, and then we say iterate over it and do this over and over and over and get that dog count. Now, functional programming, on the other hand, is a programming paradigm, a style of building structure and elements in computer programs that treats computation as the equivalent of mathematical functions and avoids changing state and mutable data. So the last part is very important. The mutable data part is definitely important. You're going to see that coming up. Let's take a quick look at a functional example. You're also going to see this. And let's not worry too much about what's going on here. We'll definitely explain that more coming up in the course. But you can see here we have the same array list. And now look at, I'm saying to system out, take dogs, and even if you don't know anything about Java 8 and streaming and what's going on in there, you probably can guess what this code is doing. So it's going to take a stream from the list of dogs. It's going to filter that where the dog's length is equal to 6. Now we're going to collect it to a list, and then we're going to return back the size of that list that we collect everything to. So even if you didn't know the specifics about Java, the programming language, and collections inside Java 8, you'd have a good chance of figuring out what's going on in this code. And that's a trait of functional programming languages where you're telling it what to do. And actually, let's take a quick look at the two compared. So imperative, we're going to say how to do it. Remember, we're setting up an iterator there. Declarative, we're saying what to do. We're more focused on the what. Imperative is going to be mutable, while declarative is going to be immutable. And you can see we did transformations there. So we took that list, we filtered those items, and we transformed it into a new list. So imperative is going to have side effects. Remember, we are updating variables. Declarative, you're not updating variables. Imperative, you're going to be passing objects around. And declarative, of course, you can still pass objects, but you're also going to be working with functions. Imperative, it's hard to compose, while functional, you have functional composition. We'll be seeing more of that. And then we didn't talk too much about it, but imperative, because we are changing mutable objects, it's not thread safe. So we need to be concerned about concurrency. Where on the other hand, if our objects are immutable, they're not changing, we get thread safety for free. So let's take a closer look at mutability. Mutability are objects that can change, and mutable objects do not change. And here's an example of mutability. So we have our dog count, and every time that we go over that iterator, we're incrementing that dog count, so that every time we loop over that property of how many ever dogs are in the list, we are going to be changing the state of that variable. So mutability versus immutable, some traits that we can look at. Mutable objects are error prone and hard to understand. I've spent hours looking at code trying to figure out what variable is getting updated by who and what. So it can get pretty darn confusing when you have a lot of moving parts that can change. While immutable objects are easier to use because they don't change. And then also we get the thread safety for free. And if we're using mutable objects, now we're going to open up the door to concurrency problems, so we can get thread safety. And in the famous words of IBM, with thread safety issues, unpredictable results may occur. Now, final variables in Java, that's something that some people confuse, and that's not the same as being immutable. Final variables still can be mutated because final just says once we initialize that variable, it cannot be reassigned. However, if we initialize that object, the state of that object can change. So if the properties are not final, we can go in and update that variable all we want. Now, you've seen me use this a number of times with Spring. I feel, and the Spring community in general feels, that it is a good programming habit to make injected properties final. So here I have this is out of the movie service that we saw before in the class, and I'm injecting in the movie repository, and I'm using the language constructs of Java to make sure that movie repository can never be changed. So the movie repository itself is welcome to change its state. So it could and potentially be mutable. However, in this class, that reference to the movie repository is never going to change. Now, we have pure functional versus functional style languages. Pure functional languages will not allow any mutability, and Haskell is an example of that. So Haskell just says, no, you're not going to mutate anything. Functional style languages will encourage mutability, but it is not strictly enforced. Java is a functional style language. Now, you'll be seeing more examples of this coming up. So Java does protect you from yourself, but it is not 100%. You can figure out ways around it. So it does try to defend against mutability, but it's not 100%, and you can shoot yourself in the foot. Now, functions can be passed objects, they can create objects, and they can return objects. The next level is higher order functions. We're going to be seeing a lot of examples of these. They can be passed objects and functions. They can create objects and functions, and they can return objects and functions. So this is a very key feature, and this allows Java to support higher order functions, and we're going to be leveraging higher order functions within the Java language going forward in this course. So in this video, we're going to take a look at going from imperative to functional programming. And we want to take a look at a couple different scenarios. Now, you can see there on the screen on line 14 to 19, I've got a little comment there about the 4 properties of a function. So think about what's going on with a function. We're going to give it a name, a return type, a parameter list, and then, of course, the body of the function. So let's take a look at first imperative style. So pretty simple example here. So I'm going to create a new thread, and we have an anonymous inner class there, new runnable, and we're going to provide a little function in there saying, or not a function, a method that's just going to run and say I'm in thread 1. It's going to toss it out to the console, and then we're going to go ahead and start it, and then in main test. So let's take a quick look at runnable. So runnable is just an interface, and we are going to, you can see that's been defined as a functional interface inside of Java. This is part of the JDK. So it allows us to create it with a function. So we're passing in, or not here, we're not passing in a function at this time. We are doing a traditional inner class. So let's go ahead and run this, and we'll check out the output of that. And you can see that the main test actually started up first, and then that started and ran just slightly after it. So nothing too earth-shattering there. Let's take a look at the next example here and see what we can take away from this noise. We're going to pass in a lambda, and I got a message there, silence of the lambda. So now notice that we no longer really need the name. That can get tossed out, and the return type. This is type inference. So we are inferring the type, so the compiler knows what's going to be returned by this. So we can come in and define this. So, and let's go ahead and run this. And you can see that that runs the same. And notice the difference here. I got some more comments in there, but the constructor is really a high order function. So it's sending a function in here. So just remember, we have to set open parens like that when we have no parameters. We need to indicate to the compiler that there is no parameters expected. And in this, we're just going to do a system out print line. So pretty simple example there. Now let's take a look at iteration. Iteration's got some pretty interesting examples that we can go through. So I have a list iterator here. I'm creating an array of dogs. And if you know me very well, I'm kind of partial to Wislas. I own 2 of those little red hounds. And here, this is like old school Java. Even the IDE's telling me that I can do this, but there's a number of things going on here. You probably coded this, have been coding Java for a while, you know all this, but there's a lot of complexity there. I mean, you're specifying the iterator, you're creating the iterator, you're handling all the responsibility for walking over that list. So let's go ahead and run that. We can see that this is going to run okay. And that runs right away. Now let's step this up. I think, I'm trying to remember, I should have done my homework, but I think this for loop syntax was introduced to Java around Java 6. I could be very wrong on that. So you can see that the syntax here is a little bit nicer. We are going through and we're just saying for, and then we're giving it a property of string and out of the dogs, and we're going to loop over that. So this is simpler, but we're still telling it about the iteration. So let's go ahead and run this guy here, and we can see him run quickly. Now let's take a look at something a little bit different, and this is a little more verbose. Now we're going in and we're using the Java 8 for each, and we're going to pass it into a consumer, and we've gone in and done an implementation of that consumer, and it's going to go in and accept a string, and it's going to do our print line. Let's go ahead and run this guy. You can see that runs happily. And now let's take another look. We can simplify this further, and that consumer can actually be implemented as a function. So let's take a quick look at this. You can see that this is a functional interface inside the new Java. This is a Java 8 feature. So it's a functional interface that we can implement. So we can implement that as a function. So here, this is our function here on line 93. And it's going to run that, and it's going to run the same way. That's a nice feature inside of IntelliJ, putting the run dialogues right in the gutter there. And you can see that this is now reducing a lot of the clutter, but we can actually take this a little bit further. We can clean this up further. And I'm going to leave that expanded. So what we can do is eliminate the type declaration there, and that's not needed because a compiler can infer that, and this will still run. But we can even take this a little bit further. And we don't need the parens. And you can drop that. The rule is you can drop that if you only have one parameter coming in, that you're welcome to drop that. So you can clean up your code a little bit further. And we still get the same output. Now, we can even clean this up further using method references. So there's another Java 8 feature to use the method references. So we can go ahead and run that, and we'll see that it runs because the compiler knows that we have a string coming in. System out println also accepts a string. So all that can be inferred by the compiler. So we still have type safety. We're not doing any type of dynamic typing here. So that's still working fine. So we still have a strongly typed language, but the compiler is able to look at what we have and say, okay, I have a string here, and it gets rid of a lot of the ceremonial code. So let's collapse all this. I want to contrast these two examples here. So we went from this, so there on line 81 to 86 is the equivalent of this. So the Java 8 stuff really gives us some powerful tools to work with. Now we're not done there yet. Got a couple more things here I want to show you. So collapse these, and now think about an example where traditionally, if we want to do a count of, let's say we want to count dogs with 8 characters, or I should call this 6 characters. Let's make that 6. So I just stopped getting confused. So we're going to do a count with dogs with 6 characters in their name. And if you're doing this traditionally in the imperative way, this here is an example of how you can do that. And we're going to create a variable called dog count. And now we're going to go through and loop through that string. We're using the external iterator still, and we're going to go through and check each one. Now, if we do that, we are going to be incrementing the dog count if we find a hit. So as we loop through that, and then we're going to fall out of it and print a dog loop. Now, what I want to point out here, one, is we are using an external iterator again, and two, this variable is mutating. So this is where you can get into trouble. If you're having multiple threads accessing this at the same time, you could get some funky stuff to happen. But here, this is just a real simple example, but let's go ahead and run this. And that runs okay, but we can really clean this up and go to a pure functional style here. And we haven't talked about Java streams yet, but Java 8 gave us a stream functionality, and it's kind of like an iterator. We're going to get into streams and a lot more in the course because they are very critical to what we're doing. But right now we're talking about functional programming. So I'm going to take a stream of the dogs, and I'm going to filter it based on where the dog length is equal to 6. And I'm going to then take all the results out of that and put them to a list. And then I'm going to return back the size of that list. And notice nothing's mutating. I don't have a variable that I'm incrementing. Everything's going through that. And what I like about this code is even if you didn't know what was going on here, if you didn't know the language, you could look at this and really start figuring it out. Because you have a nice example there. We're going to get a stream of dogs, and then we're going to filter based on the length of the dog, the length of the string, and then we're going to collect that to a list, and then we're going to output the size. So if you're brand new to Java from a different programming language, I don't know if you can get away with it if you're brand new to not being a programmer, but this is an example where you could see exactly what's going on. And we are going to be working a lot more with streams coming up in this course. Okay, in this video, let's take a little closer look at some closures and effectively final and lazy evaluation. So I'm going to show you how all this stuff plays together here. So on line 15, I've got a little test here. We're going through a list of numbers, just 1 through 6. And what we're going to do is multiply them by 2. So let's go ahead and run this guy. And we'll get the output of it. So we're doing a stream function on that. We're going to map it to the property, so we're going to return back the number times 2, and then the next for each one of those we're going to do a for each. And again, that's the Java 8 method reference there on line 20. So you can see the output there. Everything got doubled. Everything's just fine there. Now what if we wanted to externalize the multiplier here? So what we can do is assign it to a variable, and this is called lexical scope. So what's happening is now our lambda is going to close over this here. So that's how if you say it quickly, you get to closure. So kind of how that word came about, I so believe. So just keep in mind that the lambda is now going to be looking at this. So this is going to be within the scope, and we'll be able to access it. So now if we run this, we can see that it does run happily. And what should be happening is if we do a final here, Java is kind of doing an implied final for us. So when we run this, we can run it like so, and we still get the same output. Now, if I try to change it, here, we can see right away IntelliJ is complaining that we can't do it, but we'll run it so we can invoke the Java compiler, and we can see that we can't change this. So let me comment that back out, because otherwise my test won't compile anymore. Close this guy, and let's take a closer look at it. Now, if I remove the final keyword and run it, you can see that IntelliJ is already complaining, but now you can see the error message that we're getting back from the Java compiler is final or effectively final. So this is something that was introduced in Java 8, and technically what it wants us to do is declare that as final, but since we are not, it's kind of implying it for us. So kind of unusual for Java, at least in modern versions of Java or previous to more recent versions of Java. I'm kind of accustomed to all the ceremonial type code. So here it's kind of an implied contract with Java, the Java programming language, to treat that as final. So we want that to be effectively final. And remember, we don't want any mutating state here inside our functions. Now, of course, as you know, the final is just a way of saying that we're not going to reassign that variable anymore. So let's show you this code here. And of course, this is legal to do. So we can come in here, and now if I even declare this as final, that multiplier variable doesn't change. So it's legal to take that array and change values on it. So this will actually run. And we can see that it runs happily even though I'm doing a reassignment. Now, what I want you to take a closer look at is, think about for a second right here. So I'm coming in, I'm assigning the multiplier to 2. Now, what if I change it to 0? Even though I'm running up here, what do you think the output is going to be when I run it? Is it going to still be doubling them, or is it going to change to 0? So let's go ahead and run that now. And you can see that everything is set to 0. And what's happening is, and this is an example of lazy evaluation. So when you get into functions like this, it doesn't run until it actually has to. So this gives us a lot of efficiencies in the code. And even though I'm calling the statement up here, this map function doesn't get called until down here on line 75 when we're on that number stream and we're going through the for each. That's what's actually going to invoke this whole chain up here. So we're used to an imperative style type of programming, but we need to realize that this is actually going to be lazy evaluation. So all the Java 8 streaming stuff is lazily evaluated, and it does give the Java programming language a chance to do a lot of optimizations for us along the way. And we'll be seeing more examples of that coming up in the course. But this is an important concept. Even though I've done this, and I do want to point out here very emphatically that we do have a final variable here, and we want immutable state. So we kind of did an end run on Java because we are doing a final variable, but we are going in and changing the state of that variable. So we're kind of doing an end run on Java. This is not something that you'd want to do in any type of production style code. This is just as an example to show you how the lazy evaluation works. So when you are doing functional programming, this is definitely something you do not want to do. So this is a very poor programming example. But like I said before, this is to show you how this is being lazily evaluated. All right, this concludes the section on functional programming. So we got into functional programming a little bit. I hope you can see the power of functional programming. This is still fairly new to me, myself. I haven't done a ton of functional programming, but it is some really cool stuff. I like it. It's very nice to be able to go through this type of approach of declaring the functions. It's a very, very powerful tool set. It is definitely a paradigm shift from the traditional imperative model that we've seen with Java all along, where we are going through and declaring things as we go through the code to go to a functional style and functional composition. So these are very important concepts, and it is definitely a paradigm shift. Don't worry if it doesn't feel very natural. As you work with it more and more, this will become more and more comfortable. So if you think back when you just started with object-oriented programming, I know personally I went from writing a lot of SQL and procedural type coding to an object-oriented world, and that was a huge paradigm shift for me to personally go through. Functional programming is very similar, feels a lot like that, because we've been doing object-oriented programming for a long time. Now we're getting over to the functional programming world, and it is definitely a different paradigm, but also a very powerful paradigm, especially when we're dealing with large streams of data. So if you are uncomfortable with anything, go back, rewatch the videos, or drop me a note, and if you have any questions, let me know, and I'll try to address those.